Hello. Today we're gonna try to do a question about integration. And this kind of question is pretty common in many A-level or AV high-level tests. And it's the kind of things that easily be forgotten because before we try to integrate that, we have to do partial fractions. So the question goes something like this. Integration of x cubed divided by x squared minus 4 dx. Now, usually, in an easier question about the integration, we can always just use substitution straight away into the question. In here, if we try to substitute the x cubed, for example, into u, so we have u equals to x cubed, and then we find the derivative of u, so we get du over dx is equals to 3x squared. Then we have the expression for dx is equals to du over 3x squared. So what happened in here is that we cannot actually make the x squared minus 4 here disappear by using the 3x squared. And above all else, the 3x squared is also at the denominator. So we cannot use substitution in this case. The same thing happened if I want to try to make the u will be equals to x squared minus 4. Yeah. Even though we're gonna get du over dx is equals to 2x, right? And we get dx is equals to du over 2x. So what happened is that when we try to cancel the x in here with the x cube in here, the x cube will still be x squared. So it's not gone. So what happened is that we cannot actually try to use the substitution straight away. We have to do something about this one first. What we can do first, we can try to change this fraction into partial fraction. So basically, we want to make it into a smaller fraction as for the denominator. So what we're gonna do, we're gonna try to factorize the denominator. So we're gonna get integration of x cubed and then divide it by bracket x plus 2 and then bracket x minus 2 like this. Now, what we need to do, we need to try to make this thing into two different fractions. So we have a over the first factor of the denominator and then added by b, the second factor of the denominator, which is x minus 2. So all we need to do now is just try to find out what is the value of a and what is the value of b. Then we can do the integration after that. So how do we find the value of a and value of b? So this method that what we are going to do is called partial fraction. So how do we do a partial fraction? It's pretty simple. So what we have to make sure is that when we combine the two fractions on the right, it has to be equals to the value on the fraction to the left. Now, I'm gonna try to cross multiply this fraction to on the right here. So we're gonna end up with x minus 2 multiplied by a added by b multiplied by x plus 2. And then the bottom part will be equals to x plus 2 and then multiplied by x minus 2. Okay, now let's try to expand this bracket right here. So what do we have? We're gonna end up with ax minus 2a. Let me just try to extend the line here. Plus bx plus 2b. Now, the next step that we need to do, we need to group the x and the constant together. So this one here is the one with that with the x, and the minus 2a and the 2b are the constant. So we're gonna end up with ax plus bx, and this will be minus 2a plus 2b, okay, over bracket x plus 2, x minus 2, okay. So this everything in here must be equals to the original fraction, which is x cubed over x plus 2, x minus 2. So what happened here is that the upper part here, the denominator, must be equals to x cubed. So this one right here, yeah, it must be equals to x cubed, like that. Okay, so x cubed plus 0. So why do I put a plus 0 in here? Because we have a constant term on the left side. Now, what we need to do, we just need to group the x and x together and the constant and constant together. So we have ax plus bx. That will be equals to the x cubed right here. And then we also have minus 2a plus 2b is equals to 0. Okay. Now, let's try to do the upper part first. So we can factorize the left side here by taking out the x outside. So we're going to end up with x bracket a plus b. And that will be equals to x cubed. So we get from here is that the a plus b will be equals to x cubed over x. So that will be x squared. For the bottom part, we can move the a to the right side of the inequality. So of the equality. So we're gonna end up with 2b is equals to 2a, or we can say that b is the same value as a, something like that. Now we can just change the either a and b here into a and b, a or b, because b is equals to a. These two are the same thing. So from here, we're gonna end up with 2a is equals to x squared. So we get that the a will be equals to x squared over 2. And so does b in this case, yeah? So b will also be x squared over 2. Okay. Now, we're going to try to put x squared over 2 and as the value of a and b back into this one right here. Okay. So let me just try to make like a separation line here. So we know actually what we're going through. So let's continue up here. So we have a over x plus 2. So that will be x squared over 2 divided by x plus 2 added by x squared over 2 divided by x plus 2. Now, let's try to simplify this fraction. So we're going to end up with x squared over 2 x plus 2 and then added by x squared over, sorry, I think I make a mistake here. It's supposed to be a negative 2 in here because the b is over x minus 2. Yeah, so this is minus 2. So this one also 2 bracket x minus 2. Okay, now what we can do, our goal here is still try to find to integrate this stuff right here. Okay, however, if we also try to integrate this one, we cannot still find the answer in this case. Why is that? Because if we do substitution, let's say on the right fraction, on the x squared over 2x plus 2, if we make the x here into the u, then the x from the derivative of x squared will also be at the denominator, so there will still be x present on that one. The same thing happen if we make the u as x plus 2, so that means that the x squared still remain on the equation. So what do we do then? So what we can do now, we can try to combine these two right here. Okay, so what do we have here is that we're gonna end up with 2 x minus 2, yeah, multiplied by x squared, and then added by x squared multiplied by, what's that, x plus 2, and then divided by 2 x plus 2 x minus 2. Okay, now what we can do next is that we can try to expand this equation first. So we're gonna end up with x cubed, yeah, and then minus 2x squared plus x cubed, and then plus 2x squared. Okay, which actually came back to the original question, but wait for it, yeah. So, oh salah gue ya. X squared. Oh, sorry, never mind. So it doesn't go that way. I think I make a silly mistake here. Um, so what we can do here is that we can just try to uh make the x square in here. For example, I can make it into x squared minus 4, for example, and then plus 4, right? And then add it by x squared minus 4 plus 4, yeah? So then I can just make this thing into a fraction, into factor this one right here. Yeah. So I'm gonna end up with x minus 2, x plus 2 plus 4, and then divide it by 2, x plus 2. Add it again by x minus 2, x plus 2 plus 4, okay? And then divide it by 2 bracket x minus 2. Okay. Now, we can actually try to make each fraction right here into two fractions because there's a plus in here. So what we can do is that we can just make a fraction from x minus 2, x plus 2, divided by 2, x plus 2, added by 4 over 2, x plus 2. Yeah, that's for the for the left fraction. Now for the right fraction, we add it again by x minus 2, x plus 2, and then divided by 2, x minus 2, added by 4, divided by 2, x minus 2. Okay, now be careful. We still haven't tried to do the integration just yet. We still want to make this fraction right here more easily for us to do integration. Now we simplified this one right here. So we can cross the x plus 2 right there. And we can cross the 4 with 2 here. So this becomes 2. And we can cross the x minus 2 right here. And we can also cross the 4 and 2 right here. So we get 2. Now we try to write down the simplified version. So we get x minus 2 over 2. And then plus with 2 over x plus 2. And then add it again by x plus 2 over 2 plus 2 over x minus 2. Okay, now we want to integrate this 4 fraction right here. Okay, so that's the first step that we need to do before we do the integration of this question right here. Okay, now I'm going to erase this one right here. So now we have something to work with. Okay, I'm gonna move this one into the right side because we need to work on this right now. Okay, now we can integrate one by one on this fraction, starting from the x minus 2 first. So integration of x minus 2, well, this one is over 2, right? So we can actually write that down as half, yeah, multiplied by x minus 2. Then you can just move the half to the front of the integration, right? So we're going to end up with half integration of x minus 2 dx, okay? So we can integrate this one straight away. So x minus 2 integrated, x becomes half x squared. So we're going to end up with half multiplied by half x squared and minus 2x. Okay, and then we expand the bracket. So we get x squared over 4 and then minus x. That's the first one. Okay, now for the second fraction. The second fraction is integration of 2 over x plus 2 dx. Okay, so as you may know, when the x here is at the bottom, so we can actually try to make that integration into a ln, right? Because if you remember, let's say if I want to derivate ln x, ln fx, for example, yeah. So we're gonna end up with f derivative x over fx. Yeah, see, the one in here becomes at the bottom. Okay, so basically, if we integrate that one, then it's gonna go back to the original value. That's the idea. So from here, yeah, I can just take out the 2 outside, right? So I'm gonna end up with 2 integration of 1 over x plus 2. Now, let's try to imagine that the x plus 2 here is the fx, right? So we're gonna get the value of ln, yeah, bracket x plus 2, and then multiplied by 2, because there's a 2 outside here. Or it's just become 2 ln x plus 2. Okay, and this will be the integration for the second fraction right here. Now the integration for the third one. So we have the integration of, okay, same idea. So half and then x plus 2. Okay, so we can just do the same thing like what we did on the first one, on this one right here. Yeah, so what we have, we're gonna end up with half integration of x minus 2 dx. Okay, and this will give us half bracket half x squared minus 2x, I mean plus 2x. I forget that it's x plus 2 in here, plus 2x. So we're going to end up with x squared over 4 and then plus x, like that. And this will be the third fraction. Now for the last fraction, integration of 2 over x minus 2. So this is similar with what we did on the second integration right there, dx, yeah. So we're going to end up with 2 integration of 1 over x minus 2. So this will give us 2 ln x minus 2. Okay, and these are the result on the fourth one. Okay, now what can we do? We can just try to make them together right here. Okay, so we add them together. So that will be x squared over 4 minus x, yeah? And then we have plus x squared over 4 and then plus x, right? And we also have, what's that? 2 ln x plus 2. So plus 2 ln x plus 2 plus 2 ln x minus 2. Now, let's simplify the equation right here. So obviously the minus x and x, they're gone. So that's 0, right? And then the x squared over 4 plus x squared over 4, that's 2x squared over 4, or just x squared over 2. So we get x squared over 2, right? And then the 2 ln x plus 2 and 2 ln x minus 2. We can try to combine them together by, make it into factorize first if you want. So 2 and then ln x plus 2 plus ln x minus 2. So we can multiply them both. So we get 2 ln x, what's that? Square minus 4. Something like that. Okay. And then plus c. So in that case, the integration, yeah, of x cubed over x squared minus 4, that will be equals to x squared over 2, and then plus 2 ln x squared minus 4, and then plus c. Yeah. So this is the type of question that's pretty often you will come across the AAHL level math question or on the A level stuff. Right? And that's it for today. Hopefully that will help you. Assalamualaikum warahmatullahi wabarakatuh.